So this problem describes a container of gas that changes conditions. And so you may be tempted to use the combined gas law, which goes like P1 V1 over T1 is equal to P2 V2 over T2. But after a closer look, you'll realize that you have two unknowns. You don't know the initial volume nor the final volume. And that's what the problem is asking you to find, the change in volume before and after. So there's a couple ways you can go about this problem. And one of those ways is to use the ideal gas law twice, or use it once and then switch over to this combined gas law once you find one of the volumes. Let's start by finding what the initial volume of this gas is. I'll highlight all the initial conditions in green. The number of moles is not changing. The temperature is going from 13 degrees Celsius, which we'll have to convert to Kelvin, and 568 torr, which we'll have to convert to either kilopascals or atmospheres, because the given universal gas constants on your reference sheet are only in units of kilopascals or atmospheres. Now the second set of conditions, which are the final conditions, is the final temperature and the final pressure. Let's start with the initial conditions. So the ideal gas law goes as PV equals nRT. Let's take care of some of these conversions before we start. Let's turn Celsius into Kelvin by adding 273. So 13 degrees Celsius plus 273 is 286 Kelvin. So that's going to be our initial temperature. Now let's convert 568 torr into atmospheres. Recall the conversion factor is 760 torr is equal to 1 atmosphere. That's on your reference sheet. So that's my initial pressure. Let's plug these values into the ideal gas law. I'm going to rearrange this to solve for V, our initial volume. So V1 is going to equal number of moles, the universal gas constant, times temperature over pressure. And these are all initial values. So plugging these numbers in, the number of moles is 0.35. The universal gas constant we need is the one with atmospheres. And temperature we just converted earlier, 286 Kelvin. And that's all going to go over the pressure, which we converted to atmospheres. Now we'll cancel out the units. We have atmospheres, top and bottom, Kelvin, top and bottom, and moles, top and bottom, and we're left with units of liters. .35 times 0.08206 times 286 divided by the number of my calculator. Is 11. So volume 1 is 11 liters. The initial volume is 11 liters. So I'll circle that for now. Now let's do the same for the final volume. Now at this point, you could use that 11 liters and go back to your combined gas law, and now you can use that. But let's just do the same thing for the final volume. So I'll do that in red now. Number of moles hasn't changed, but the other two variables, the temperature and the pressure, have. Let's do our conversions first. We need to turn Celsius into Kelvin. So 56 degrees Celsius plus 273. The Kelvin scale has the same increments as the Celsius scale. It's just shifted by 273.15. So we can just add 273 to get the same value in the Kelvin scale. So the final temperature of this gas is 329 Kelvin. Now let's turn torr into atmospheres. 760 torr is equal to 1 standard atmosphere. So we got 1.18 atmospheres. That's our final pressure. Let's plug these numbers in to get the final volume. So the number of moles hasn't changed. It's still 0.35 moles. The universal gas constant, will use the same one because we converted our pressure to atmospheres. Now the temperature is 329 Kelvin. And the pressure is 1.18 atmospheres. All right, atmospheres, going to cancel numerator, denominator, moles, up and down, Kelvin, top and bottom. And we're left with units of liters. So we got 8 liters. Our final volume is 8.0 liters because we need 2 significant figures. The measurement that determines the number of significant figures is the value for moles. That measurement only has 2 sig figs. So our final answer can't be more precise than the least precise measurement. Now let's answer the question. What is a change in volume? The change in volume, delta V, is equal to the final volume minus the initial volume. So the change in volume is 8.0 liters minus 11 liters. And so the answer is -3 liters. Notice it's negative because the volume decreased. Also, when you're adding or subtracting, your answer can't be more precise than the least precise measurement. In other words, 11 liters doesn't have precision to the 10th place. It doesn't have any decimals. Therefore, your answer can't have decimals.